Okay, ladies and gentlemen, so we are back to taking notes after such a long break. This page right here will be page 92. That will be for your entry tasks. Page 93 right here, that is where your homework log goes, and you should have that already there, cut out. Keep it in like so. Have some homework next week on, again, page 93. Page 94. We're going to leave that blank, and then we're going to put our notes today on page 95. Okay, so if you have your notes, you're going to set up for Cornell Notes, of course. Line here, a line on the top, and our line at the bottom, our summary. Okay, we are going to be doing some more of these interactive notebooks. You should have one of these. You cut it in half and gave your partner half. Here you're going to cut on only the dotted section and only the dotted section. All right there. Then you're going to take and fold those in and make some nice little flaps. We are eventually going to tape this into our notebook, but I'm not going to tape it in until I'm completely done so that when I'm writing on it, I don't have to worry about writing on tape. So today, we are going to be talking about true equations and true inequalities. We're going to be able to decide if they're true or not. So EE5 is I can determine when equations and inequalities are true. Okay, it kind of sounds like a lot, but it's actually not. Okay, so we're just going to put this right here for now. And on this side of the foldable, you're going to write true, because we're going to be talking about things that are true. And you could set that up however you like. Maybe you want to put a little smiley face, make it pretty. Okay, but these things on this side are going to be talking about true equations and true inequalities. This side is going to deal with things that are not true. And again, let's spruce this up a little bit. Draw some attention to it so I remember that this has to do with things that are not true when we're talking about equations and inequalities. Okay? So, we have our foldable. Now we're going to open it up. And the first section we're going to talk about here are equations. So we're just going to write that at the top so that we remember that this part is equations. We've talked a lot about equations in the past, so we should be pretty good with an understanding of what those are. Okay? So, equations. These equations, you need to remember, they have to have an equals sign. Okay? That means both sides are exactly the same. Okay? Both sides are exactly the same. You also need to remember on all of these to show your work. Okay? That can mean doing the V. Okay, doing the V. If you remember that from order of operations, doing the V. Okay, so let's look at an example of what I mean. And this is going to seem probably a lot easier when we get to some examples. So example 1. If we had 3 plus 5 equals 8, we are going to determine, is that equation true? Okay, so in order to prove that, we say, okay,
please excuse the interruption and the request to please come to the office. Thank you.
3 plus 5 equals 8. So we write 8 right under there. Remember, that's our V. And does 8 equal 8? Yes, it's true. And it's that simple. Okay? We might have a little slightly more complex equation. If we say 3 squared plus 7 equals 16. Okay, so once again, it might not be as easy to see. Does this side, is that side exactly the same as this side? Is it true? So again, we wanted to show our work and do the V. Order of operation tells me 3 to the power of 2 is the first operation I need to do. So 3 to the power of 2 is 9, plus 7 equals 16. 9 plus 7 equals 16. 16 does equal 16. That's true. So those are true. Both of those were true. Okay? So now, inequality. Very similar, but now you have more possibilities for a true answer. So let's review what the inequality symbols are. Okay? So this means less than. The same symbol with a line under it means less than or equal. So the number can be less than or equal to the other number. We have this symbol right here, which means greater than. And then this symbol below it, again with the line, can also mean greater than or equal. Okay? Now let's take a look at some examples of how those would work. Again, these are set up just like an equation. Okay, so you might have something like 3 plus 7 is less than or equal to 10. Well, 3 plus 7 is 10. So that is less than or equal to 10. It's not less than 10, but it is equal to 10. So that is true. Okay, let's look at another example. Let's say we have 2 times 7 minus 2, and that is greater than 3. Again, we need to do some order of operations work here. We have 7 minus 2, that would be first because it's in parentheses, that would be 5. And then 2 times 5, remember the parentheses can also mean multiply, is greater than 3. 2 times 5 is 10, and that is greater than 3. That is true. 10 is greater than 3. True. Okay. And again, show your work. Notice that I have a nice V pattern right here where I've done step-by-step work down to my answer here, and then I can compare those two. Is 10 greater than 3? Yes, it's true. And this is my determine. This shows all the work and the proof that I need to determine if an equation or inequality is true. Okay? Now let's take a look at the not true side. What happens when these are not true? Take a look at those. Okay? So again, we'll talk about equations first. Okay? So, again, equals, okay, an equal sign, both sides the same. They have to be exactly the same. Okay? And again, you need to show work. Very important. Do the V. Okay? Now also in this one, you might need to use this symbol we talked about before, which means that if we put a line through here, that means not equal. You might be using that. Not equal. Okay? So let's take an example of this. Okay? Let's say we have 16 divided by 2 equals 7. Now, I know a lot of you are going, Mrs. Johnson, I can do that in my head. I don't need to show the work. But again, you do need to show your work. That's the proof. 16 divided by 2 is 8. 8 equals 7. That is not true. So you can put a line through that equal sign to say that it's not true. You can, if you want, also say not true. Okay? Those ones are not true. Okay? So let's take a look at a little more complex one. What if we have 12 divided by, not divided by 12 plus 4 minus 2 to the power of 3. Okay, that's going to equal 17. Okay, so again, when we first look at this problem, it's not as easy to tell if it is equal to 17 or not. So we need to make sure we do our work, vis-a-vis, and work out the problem step by step. Order of operations says I do parentheses first, so 12 plus 4 is 16 minus 2 to the power of 3. So order of operations says exponent next. 2 to the power of 3 is 2 times 2 times 2, which would be 8. And 16 minus 8 is 8. 8 equals 17. Oh, I can see that that is not true. I'm going to put my line through the equal sign to say that 8 does not equal 17. Not true. I'll that again for you. Not true. Okay. Now let's take a look at inequalities that are not true. Inequalities that are not true. Well, let's go ahead. It won't hurt us again to review one more time what those symbols mean. So we have less than. Oh, whoops, I'm sorry, that shouldn't have a bar under it just yet. The next one is less than or equal. And we have greater than. And greater than. Or equal. Okay? And then I would also like to say a diagonal line through any symbol above not. So if I put a line through less than, it means not less than. Just like a slash through the equal sign means not equal. The same is true for these inequalities. Let's take a look at what that would look like in an example. So example 1. 3 minus 2 is greater than or equal to 7. Okay, 3 minus 2 is greater than or equal to 7. Well, 3 minus 2 is 1, and greater than or equal to 7. Is 1 greater than or equal to 7? No, absolutely not. 1 is less than 7, so we can put a line through that saying no, that is not true. So just to write that out, 1 is not greater than 7. And what we should actually say here is not greater than or equal to 7. Okay? That is it. So it's actually, hopefully you found that not too complicated, and now you have your complete nice foldable. And now you can go ahead and take that foldable and you can tape it right in. And now I'm going to just open it up and I'm going to line it up here, and I'm going to tape the top section and the bottom section. And now I have that nice foldable in there. So when you're doing your work, if you want to take a review of how you say something is true, how you say it's not true, you can take a look here. And again, remember, I want to write this at the bottom. Remember to show your work. Prove it with Z. Okay, great. And now you guys will have an opportunity to try it.